Hello kids, nice to see you. So today we'll begin a new topic. It's uh, it's again about materials magic unit, but today in our lesson we will learn why have so many toys made out of plastic.
Hey, this is Doug. I want to show you something. I don't know if you've ever noticed this before, but toy cars, action figures, dolls, Legos. Have you ever noticed what material they're made of? So many toys today are made of plastic. Why is that? Why are so many toys made out of plastic? Well, it turns out we haven't always made toys out of plastic because plastic had to be invented. Before the invention of plastic, now I'm talking about the time of your great great grandparents, their toys were made out of a different material wood. Some of these toys were actually very nice, but there was a problem. These wooden toys took a long time to make because each toy had to be carved by hand, like this. Wooden toys were expensive because it was so much work to carve even a single toy. Even a little wooden toy like this might cost an entire week's pay. So that would be like this little toy hippo costing a few $100s. Isn't that crazy? So many parents had to make toys themselves by carving them from wood in whatever little free time they had. So most kids were lucky to have just one or two toys. You can understand why people started to ask themselves, wouldn't it be great if there were an easier way to make things? Like, imagine if all you had to do was carve one toy, and then you could just hit a button to make copies, and poof, you'd have lots of the same toy in almost no time. Now the toys would cost less to make. Every child could have more toys. What you'd really need in a situation like this is a faster, easier way to make a certain shape so that you could make lots of toys all at once. Like, what if you want to make lots of copies of this lion shape? Can you think of any way to do that? I'll give you a hint by showing you an example totally different from toys. Say if instead of toys, you wanted to make a bunch of popsicles. Like these awesome lion-shaped popsicles that are sold at the zoo. Now, what could you do to make lots of these? You know you could take a big chunk of ice and you could carve it into an animal shape. But that would take a long time, and you don't want just one. You want a whole bunch of these, the exact same shape. Can you think of an easier way to do it? How do you think popsicle companies make lots of copies without having to carve each one?
Yes kids, you want to make a bunch of lion-shaped popsicles. How do you think popsicle company make a lot of copy without having to carve each one? Answer next.
I gave popsicles as an example because notice there's something special about ice. Ice is a material which has this property where it can melt into a liquid. Like this, watch. This is an ice cube quickly melting on a hot frying pan. You see it's becoming a liquid? It's water. Water is just the liquid form of ice. Ice is the solid form of water. Ice has the property of being meltable. Being meltable is a really useful property for a material to have because you can pour a liquid into any shape you want. Like if I pour water into this ice cube tray with rectangular shapes, and then I freeze it back into a solid, out comes a lot of rectangle-shaped ice cubes. Or if you had a tray with shapes like this instead, you'd get monster-shaped ice cubes. Liquids always take the shape of the container you pour it in. So if you want a bunch of lion-shaped popsicles, all you need is a lion-shaped tray. You can keep making lots of special shapes with ice over and over again for very little time or work. But what does this have to do with toys? Well, obviously it wouldn't be a good idea to make toys out of ice. They'd melt in your hand. And wood as a material, well, wood doesn't have the property of being meltable. There's no such thing as liquid wood. Remember, most toys today are made out of plastic. You see where I'm going with this? Plastic. Why do you think toy companies started using plastic to make toys instead of wood? What do you think might be so special about plastic?
What do you think about that, kids? Maybe we can think plastic is cheaper? And maybe plastic is easier material to use, for modify, for take some shape. We'll see.
It was in the year 1856. A scientist named Alexander Parkes was experimenting in his laboratory by mixing different chemicals. When he mixed cotton with strong acid and other chemicals, he accidentally discovered a new material: plastic. One of the things that was so great about this new material was that just like ice, plastic has the property of being meltable. Like, look what happens when we heat up these plastic army men over a stove. Whoa, you see this? Plastic melts into a liquid when you heat it up. And unlike ice, which melts even when it's just a little warm, plastic melts at a much higher temperature than ice. So plastic won't melt in your hand. Once you get plastic really hot and it melts into a liquid, you can then squirt it into any shape you want. You can squirt it into a dot shape, like you see here, or you could squirt it into a Lego man shape, or toy dinosaur shapes, or any shape. So when plastic was invented, for the first time in history, it was possible to make millions of toys, since you could pour liquid plastic into a shape and just let it cool. That made it easier and cheaper. If your great-great-grandparents could walk around a toy store today, they'd be amazed at how many toys there are and how much cheaper they are thanks to the invention of plastic. I should point out to you that ice and plastic are not the only materials that have the property of being meltable. Metal and glass are two examples of materials that can be melted too, and they can be poured into shapes. If you want to see some really amazing videos of metal and glass in their liquid form, check out the videos in the extras. Right now, though, look around you. Can you think of any materials that melt?
Can you think of any other material with this property? What else melts beside ice, plastic, metal, and glass? For hint, go to the next slide. Is there anything you eat that melts? Chocolate, maybe? Butter, cheese, ice cream, chocolate, yeah. Some candy melts. How can you test different kinds of candy to find out which kind melts and which kinds don't? You have to make the experimentation.
In today's activity, you're going to experiment to find out what kind of candy melts, and more importantly, what kind of candy doesn't melt. You're doing this experiment to help a friend who has a big problem. You see, you just got a postcard in the mail from your friend. They've been gone all summer visiting a summer camp called Camp Way Too Hot, which is located in the American state of Florida. Let's read what your friend wrote, shall we? Camp is going okay, I guess, but it's 10 miles from the nearest store. We ran out of candy on day 2, and we have 2 more weeks to go. Please send candy. Now, the only way for mail to get to Camp Way Too Hot is by truck. And that truck has to drive for miles in the Florida sun with no air conditioning. It gets really hot inside. You want to send your friend candy, but you don't want it to melt in the truck and arrive as a box of melted goo. That would be a disaster. If you've ever left a chocolate bar in the sun, you know that it has the property of being meltable. Just like plastic, chocolate can turn into a gooey liquid. It loses its shape completely. But is all candy meltable? Today, your class is going to heat different candies to see if you can find one that won't melt. You'll see whether the candies stay solid, melt into a liquid, or just melt part way, getting soft and squishy. Then your class can decide what kind of candy you would send to Camp Way Too Hot. You ready to begin? I'll talk you through the steps one by one.
So we cannot do these activities. We will see how they do.
Your teacher will pass out hot water. Put it on the plate, but don't open the lid yet. Open your container and put in the bags of candy.
So hot water will maybe melt some candies.
Use your sticks to push the bags underwater for 2 minutes. Discuss these questions while you wait. I'll put a timer on screen so you know when 2 minutes are up. You ready? Here we go. Look at the candy while it's still in the hot water. Did it lose its shape? Circle your answer on the worksheet.
So the chocolate changed its shape.
Take out the bags and squish the candy with your fingers. Now your teacher can ask each group for their results, or in other words, what you discuss these questions.
Okay. So we'll see if we have some other video to see. Good job. How did this glass bottle get so stretched? Watch the glass video on the next slide. Maybe we warm the bottle and after we can have the shade we want with this bottle. Yes, glass melt is very cool. Beautiful metal melts. Wow, we are lucky. So she warm glass. Stylish. She had hair for make a big bubble. That's very cool. When glass is not enough, it stretch and bend easily.
Maestro va a creare un cavallino con la tecnica elettromassiccio. Now we get the creation of a little horse just shaping the glass by glass.
perché mi ha temperato.
Okay. And now let's
Alright, with that warming up, let's round up some.
see from the beginning.
In this project, we're using backyard science and a bucket full of soda cans to make a batch of mini metal biscuits. Let's start this project with the mini metal foundry we made in another video in a big bag of charcoal briquettes. These might look like the kind for barbecuing and grilling, and that's because they are. When 5 briquettes are spaced evenly at the bottom, we're ready to add a crucible like this one I made out of a steel fire extinguisher, and I found that putting the container on a layer of charcoal helps melt the cans faster once we fire it up. Now let's connect a 1-inch steel pipe through the air supply port on the side of the foundry. This will get the fire hot enough to melt metal, but we still need a way to shoot the air in. We could just blow through it, but a much better idea is to use a hairdryer, which you can find at most thrift stores for about $3. Now I taped the hairdryer to some PVC pipe and inserted a couple of 1-inch couplings to connect the steel tube at one end and give the blower tube a quick release feature. This way it's super easy to take apart and fits into a 5-gallon bucket for easy storage. Now since the blower tube is at a strategically placed angle, it's really helpful to support it so it doesn't strain the foundry. This little trick will help keep the walls from cracking and increase the life of the unit dramatically. Now that the foundry is all set up, let's fill it to the top with charcoal and breathe some life into them the same way you'd light up your barbecue. My tool of choice is a propane torch because it gets everything heated up in a hurry. The coals are burning, so let's flip the hairdryer to the low setting and blow a steady stream of oxygen on the charcoal to really heat things up. You can see how the cover we made keeps the heat inside so it conserves energy while it's bringing up the temperature. The coolest part is that the crucible lines up perfectly with the hole in the center. Alright, with that warming up, let's round up some soda cans, like these ones I got from a local recycling depot, and this important tool that makes the whole operation possible, a pair of steel tongs from the dollar store. After 10 minutes, you can see the foundry is scorching hot, and the handles probably are as well, so let's use the tongs to carefully remove the top without getting burned. You can see the steel crucible is glowing orange, and that means it's ready for action. The container is 3 inches wide, which is the perfect size for melting standard size soda cans like these, and at temperatures over 1000 degrees Fahrenheit, you can see it'll liquefy them in just a few seconds. Now I cranked it up to full power to melt more cans in a hurry, and averaged around 10 to 12 cans per minute. The cool thing is that it doesn't matter if the cans are dirty, painted, or still have soda inside. The furnace eats anything and pulls out pure liquid aluminum, which you'll see in just a second. In my experience, 38 to 45 cans produce around 1 pound of molten aluminum, and if you try crushing your cans first, you can melt them with the cover in place so less metal will get oxidized in the process. Now after liquefying about 50 cans, you can see the container is completely full, but there's a lot of gunk floating around that we really don't need. The easiest way to isolate the aluminum is with something like this steel cake pan I got at the thrift shop for 50 cents. First, let's go ahead and carefully remove the crucible, making sure we've got a very secure grip with our tongs. Then very slowly pour the liquid into the steel mold. You can see the slag stays behind and almost acts like a strainer, helping prevent anything solid from flowing downstream. Now that we've separated the good stuff out, why don't we tap the container on a slab of concrete and dump out the dross. By keeping our crucible clean, we can use it again right away. Now just for fun, I tried melting a bunch more cans so I could pour them into a brand new cupcake pan. The hope here is that this fancy pan will give a cool and unique look to the aluminum ingots when they cool. The pan is made of steel, but it's catching fire because the non-stick coating is burning off, but this will be the only time it does that. After a couple of minutes, you can see the ingots have hardened, but they're still blisteringly hot. So much so that they'll ignite a piece of paper instantly just by touching it. Now it's a really good idea to have a bucket of cold water nearby so you can cool them down. When they drop into cold water, you can see they're still hot enough to bring the water to an instant boil, but after about 10 seconds, they cool to the point where you could pick them up barehanded if you wanted to. Now I also tried pouring ingots into a mini muffin pan to get a smaller variety, and ended up with some really adorable mini metal muffins. These ones are actually my favorites now because they're so easy to work with. The purpose of an ingot is to keep some pure metal handy for when you want to make something cool. So now that we have some, all we have to do is fire up the foundry and toss a few nuggets into a clean crucible. This setup can liquefy ingots in 5 to 10 minutes, and check this out. By melting clean ingots, there isn't any dross we have to fish out either. Instead, there's only a thin skin of aluminum oxide, which means this entire crucible is full of molten aluminum ready for casting. I tried pouring mine into a 5-gallon bucket filled with sand and one other specialty item, which you can see bursts into flames and absorbs 2 full pounds of liquid metal.
After 5 to 10 minutes, the metal is hard enough to grab onto with a pair of channel locks so we can break the mold and reveal the casting inside. Watch for how to make something like this in another project video.
Wow, it's so cool. I would like to see other video like that, definitively. Okay, kids, let's stop for today. If I find other fun video like that, we will watch together. Have a good day, take care of yourself and take care of your family. See you.